everyone. I am Dr. M. Laxmidevi, Associate Professor in the Department of CLCDS at Institute of Aeronautical Engineering. Today's topic is C tokens. So let us see what are C tokens. C tokens are the basic building blocks in C language. So these are constructed together to write a C program. So basic building blocks in C program are called as C tokens. So for example, if we want to construct a house, then bricks are the basic building blocks to construct a house. Similarly, in C language also, C tokens are the basic building blocks to write the program. So here, in other words, you can say that it is the smallest unit in a program or statement, and the compiler identifies them as tokens. Now let us see what are the different types of tokens available in C. So these are the different types of tokens which are supported by C. So these are keywords, identifiers, then constants, operators, special characters and strings. Now let us discuss about each one in detail. So first one is keyword. So what do you mean by a keyword? So in the C tokens, keyword is the first C token. So keywords are reserved words by the compiler. So you can say that keywords are nothing but reserved words by the compiler. So keywords cannot be used as variable names. So what is a variable? So we'll discuss in the next slides. In order to utilize these keywords in the program, so we need not include any header file in the program. So in C language, there are total 32 keywords. So 32 keywords are supported by C language. Now let us see what are the different keywords which are available in C. So first one is auto. Then we have break, case, the character, char, then constant, continue, default, do, and then after that we have double, else, enum, extern, float, for, go to, if, then int, long, register, return, short, signed, size of, static, then struct, switch, typedef, union, unsigned, void, volatile and while. So these are the different keywords which are available in C. Now let us understand this one program where we use keywords. So here in this program, so this is a simple program. So where we have one variable and its value is initialized to 10, and we are printing that value with the help of printf statement. So in this program, so here we can see that this bold color int, so here int is a keyword, and then again return is also a keyword which is used in the program. So once again, so in order to use the keywords, no need to use any header files, no need to include any header files in the program. So these are automatically detected by the compiler. So we know, but there is a rule to write the keyword. So all the keywords, as you can see here, so these are in small letters. So C is a case sensitive language. So all the keywords, they must be in lowercase. So that is what you have to follow when you're using a keyword in a program. Next is identifiers. So the next one is identifier. So what is identifier is, it is nothing but a symbolic name which is used to refer to a variable, constant, function, structure, union, etc. So, or in other words, you can say that identifier is a name given to an entity. So that entity, it can be a variable, it can be a function, it can be a pointer, or it can be a structure, union, or array. So identifier is nothing but name which is given to an entity. So entity can be variable among all these which have been defined here. So let us see. So there are some rules to be followed for identifiers or for constructing identifiers. So as you can see here, identifiers are user defined names. So these are defined by the user. So there are certain rules to be followed for constructing C identifier. So let us discuss about these rules. So when you're defining. So for C identifier, the first character of an identifier should be either an alphabet or an underscore. And then it can be followed by any of the character, digit or underscore. Next point is it should not begin with any numerical digit. Then in identifiers, both uppercase and lowercase letters are distinct. Therefore, we can say that identifiers are case sensitive. So some of the other rules are C identifier does not allow blank spaces, punctuations and signs. So keywords cannot be used as an identifier, and the length of the identifier should not be more than 31 characters. So identifiers should be written in such a way that it is meaningful, short and easy to read. So these are some of the rules to be followed when we are writing or when we are constructing C identifiers. So these are some examples of valid identifier and these are examples of invalid identifiers. So valid identifier, as you can see here, the first character is an alphabet. So it can be either small letter or capital letter. And next is, so this is valid, this one is valid. So here this identifier, it has lowercase as well as uppercase letters. So therefore this is also valid. This is valid, and then the starting character can be underscore also. Therefore this is also valid, and in between also you can have an underscore. So all these are valid examples of an identifiers. Then invalid identifiers are, so here you can see that here we have given space. So this is invalid identifier name. So here's operator is given. This is invalid. Then here one special symbol is there. This is also invalid. And here it is starting with a digit. So therefore this is also an invalid identifier name. So in the program, for example, if we are writing int num, so in the program if we are writing int num, so here int is a keyword and num is an identifier. Now in C tokens, so let us see about the next one, that is constants. So what are constants? So constants in C here, these are values which are constant. That means they do not change during the execution of the program. That means throughout the program their values are constants. So in C we have mainly two types of constants, numeric constants and character constants. Now let us see one by one. So first one is numeric constant. So in numeric constant, first one is numeric constant. In numeric constant again we have two types, integer constant and the other one is floating point constant, or you can say that real constant. So in numeric constants we have two types, integer constant and floating point constant or real constant. Now let us see first one, integer constant. So what is integer constant? So these constants are represented with whole numbers. So they require a minimum of 2 bytes and maximum of 4 bytes of memory. So these are the following concepts are essential to follow numeric constants. So numeric constants are represented with numbers. So there should be at least one digit for representing the number. So decimal point, fractional part or symbols, they are not allowed for numeric constants, and also blank spaces and also commas are also not allowed. So integer constant, it can be either positive or negative, or it can be 0. So a number without a sign, so that is assumed to be positive. So these are some valid examples. Some examples of integer constant. So this is an integer constant. This is 1020. So by default, if we don't assign any sign, so that is considered as positive. So here positive sign is included. This is also an integer constant. This is also an integer constant. So invalid integer constants are, so as you can see here, decimal point and fractional part, they are not allowed. So decimal point, this is invalid constant, and then special symbols are also not allowed. So, and then therefore these two are invalid examples of invalid integer constants. Next one is, so there are Integers can also be represented in octal or hexadecimal number. So in integer constants, so we have mainly 3. So we can represent a particular number in decimal form. The other way is octal and then hexadecimal. So in integer constants again, we can represent integer constant in 3 forms. First one, decimal constant, octal constant and hexadecimal constant. So that is what here. So octal number system, it has a base 10 and hexadecimal number system has a base 16. So decimal number we have from 0 to 9. Then octal number from 0 to 7, it has a base 8. And then hexadecimal number, so it is from 0 to 9. And then after that you can see here, hexadecimal numbers are from 0 to 9 and then from A to F. So octal numbers are from 0 to 7 and hexadecimal numbers are from 0 to 9, A to F. So representation of octal numbers in C is done with leading digit 0. And for hexadecimal numbers, so we add leading 0x. This can be either capital letter or it can be a small letter. So examples of octal and hexadecimal numbers. So examples of octal and hexadecimal constants in C. So any digit, if we have 0 at the beginning, then it is, for example, this number. So this is an octal constant. This is octal constant. Why? Because we have 0 at the beginning. This is an octal constant. This is also an octal constant. Next one, hexadecimal number. So representation of hexadecimal number in C is, so at the beginning we have 0x. So this x can be either in small case, it can be smaller, it can be small letter or it can be capital letter. So 0x9 and 0x9. So both of them are valid. 0x. So suppose we have A, G. So this is invalid. Why? Because we don't have G here. So this is invalid. So this is invalid representation of hexadecimal number in C. Next, in numeric constants, the next one is real constant. So what are real constants? So real constants, they are also known as floating point constants. Real constants are also known as floating point constants. So real constants, we can represent them in exponential or fractional form. So many parameters or quantities, they cannot be defined with integers only. So therefore, for that purpose, we require real numbers also. So for example, so length, height, price, distance, etc. So are all measured in real numbers. So therefore the concept of real constants. So following concepts are essential to follow the real numbers. The decimal point is permitted. So for defining real constant, decimal point is permitted. So we cannot have blank spaces or commas. Next is real numbers. It can be either positive or negative, and the number without a sign is assumed as positive. So examples of real constants are 2.5, this 5.521, 3.14 and etc. All these are examples of real numbers. Then real constants, they can be written in exponential form also. So exponential form which contains fractional as well as exponential part. So for example, if we have this, so this is a real constant. So this can be written in exponential form as 2.4561 into, so this can be written as 2.456123 into 10 power, so 3. So this we can write in exponential form as 2.4561, so into e power plus 3, because we have plus 3 here. So the part that precedes E is called as mantissa. So this is the mantissa, and the part which follows after the exponent, after the E, that is called as exponent. So here 2.456 is the mantissa and plus 3 is the exponent. So in order to declare a real constant, or in order to construct a real number in exponential form, so following points must be taken into account. So real number, it should contain mantissa and exponent, and the letter E should be there to separate the mantissa and the exponent. And it can be either in uppercase or in lowercase. The mantissa should be either a real number represented in decimal or integer form. The mantissa, it can be either positive or negative, and the exponent should be an integer. So that can be positive or negative. Some valid examples of real constants are in exponential form is 5.2 e power 2. Then minus, so this is also a valid example. This is also a valid example. Next type of constant is character constant. So in constants we have seen that, so there are two types. First one is integer constant. Next one is real constant. So real constant also called as floating point constant. So these two comes under numeric constant, and the next one is character constant. So in character constant we have again two types, single character and then string constant. So first we will see single character constant. So single character constant is, it consists of single character. A character constant is a single character. So it can also be represented with single digit or a single special symbol or white space enclosed within a pair of single quote marks. So for example, if you write this, so this is a single character constant. Character constants are enclosed with single quotation marks. So valid examples are, so A in single quotes. This is also a valid character constant, single character constant. So length of the character at the most is one character only. So character constants, they have integer values known as ASCII values. So for example, if we write the statement printf %c and %d, comma 65, comma b. So here it will display, so percentile C, corresponding value 60. So that is A. It represents the character A, and this B value represents, and the integer constant, and the integer value of this B is 66. So it will display, for example, this printf statement will display character A and 66. Next one is string constants. So string constants are a sequence of characters which are enclosed within double quote marks. So for example, if you write, so these are some valid examples, hello, India, this one and this one. So all these are, so you can note here that, so this is a string in double quotes, whereas this is a character. Both of them are different. So string constants, so here length of the string is 1, 2, 3, 4, 5 and 6, because at the end \null character is also added automatically by the compiler. So anything, so if you write in double quotes, so that becomes a string constant, and if it is, if a character is in, if you have a single character in single quotes, then it is a single character constant. Now let us see. So till now we have discussed about the tokens in C. So C tokens, we see that, so C tokens are keywords, identifiers, and then constants. So these are the tokens we have discussed till now. So let us revise once again. So keywords are nothing but these are reserved words. These are reserved words which are defined by the compiler. So in order to use these reserved words, no need to include any header files in the program. So there are 32 keywords in the C program. Next is identifier. So identifier is nothing but the name of an entity. So that entity, it can be a variable, it can be a pointer, it can be a function, then array, structure, union, etc. So all this comes under identifiers. So also we have seen the different rules to be followed for constructing an identifier. Some of the valid examples of identifiers are int a. So here a is an identifier. Suppose we are writing int 1a. So this is valid identifier, but this is not a valid identifier because we have used a digit here. So according to the rules, we should not use any digit at the beginning. Then we can use underscore here. So this is a valid identifier name. Then int sum, int sum. So these are also different. So these two are different. These are valid identifiers. But here we have used smaller case letters, whereas here we have used capital letters. Next is constants. So what are constants? So constants are, their values are fixed throughout the execution of the program. So their values cannot be changed. So constants, we have seen that there are two types. Numeric constant and the other is character constant. So in numeric constant, we have, again in numeric constants, we have two types. Numeric constants, we have two types. Real constant and the other one is integer constant. So integer constants can be in decimal form. Integer constants can be in decimal form, hexadecimal form or octal form. Then we have real constants. So these are also called as floating point constants. So floating point constants, so for them, so example of floating point constants is 2.3, etc. So here we represent the real constants in terms of decimal. So there should be a decimal here. Next is, again the second type of constant is character constant. So in character constant, we have single character constant, single character, and then string constant. So single character constant, so any character, it consists of single character enclosed in single quotes, whereas string constants, so it is same enclosed in double quotes. So any character or sequence of characters, string, you can say that it is nothing but sequence of characters. So A, B, C, this is also valid. So any sequence, string is nothing but sequence of characters which is terminated by null character. So these characters enclosed in double quotes, so that forms a string constant. Now let us see. So we have used the term identifier and variable. Now let us see the difference between identifier and variable. So what is identifier? Identifier is nothing but the name given to a variable, function, class, structure, union, etc. Whereas variable is the name given to a memory location and which holds a particular value, and that value can be changed during the execution of the program. So it is created to give a unique name to an entity. So variable purpose is also the same. It allocates a unique name to a particular memory location. So we can say that all identifiers are not variables. but all variable names are identifiers. So let us understand this statement with the help of one example. So here you can see that, so we have declared a variable of type int. So here a is an identifier. So here also you can say that this is a variable, and here this is the name of the function here. So a, and then this is the name of the function. So here a is identifier, but here a is a variable. Now let us understand this with the help of one example. So float area. So if you declare a variable area of type float, so here float is a keyword and area is identifier. So identifier area is name given to a variable, so which will store a float value. Now if area wasn't a variable but it is a function now, so now we declare the area with function name. Now area is nothing but function name. So syntax for declaring a function is, or defining a function is this. So here area is still an identifier, but this time, so identifier area is name given to a function. So therefore this is an identifier. So this is the main difference between identifier and variable. Now there is one more example here. So in this example, so we have, so this is a function name, and in the int main function, so we are calling the function with the same name. So here this my is an identifier, whereas in this example you can see here, so we have declared, so here int my is a variable. Here my is a variable of type integer, so it contains values of type integer. So here my is a variable, but here it is a function. It is an identifier, it is an identifier because it is the name given to a function. Next, rules for creating a variable or constructing a variable, they are same as we have seen for identifier. So it can contain any combination of alphabets, digits or underscore. So initial character of a variable name should be an alphabet or an underscore. As it is an identifier, some of the rules are similar for both identifiers as well as variables. So use of commas and blanks, they are not permitted within a variable name. And also, so we cannot use any special symbols also. For example, if you write this ABC, so this is also not a valid name for a variable. This is not a valid variable name. So you cannot use any special symbols except underscore. So one more example to illustrate variable. Suppose we have declared a variable of type float area, and we are assigning its value to 24.01. Now you can see here, so this is the variable name and this is a value. This is a value stored in the memory location, and area is a variable name. So that is nothing but the name allotted to the memory location 2000. So suppose for example, so this value is stored at location 2000 and area contains the value 24.01. So this is the address of memory location. So this signifies variable name. This is the value in the memory location 2000 and this is the address of the memory location. So thus we have seen some of the tokens in C. So the tokens which we have discussed till now are identifiers, keywords, and the next one is constants. Apart from this, there are some more tokens like special symbols, special characters. Then we have strings and also we have operators. So those we will discuss in the next video lecture.
Like, share and subscribe. Hit the bell icon for more updates.